So I have to make a program which could load in a text file and based on that text file create graphics upon by reading this text file. I have included the f stream and I included string f stream so I can stream in files so we can read the file and the program can read the file. Doesn't matter if we can read it, as long as a program can do it and create some graphics upon it. It is nice. We have different variables here for integers and strings, which we have used to divide our text file here into smaller pieces, so the program can recognize those small pieces as strings or integers or floats, and thereby creating what we want to create. Pretty nice. And then we have some 2 pointers down here for data and pixels and the off texture called image texture, which we have used to input this image here because it's coded in a little different way than this one, because we want to manipulate on this source, for example, scaling it down or inverting the colors of it or anything else. That's nice. So let's, and at last we have off, and put this off image called time, so we can load in the images we want. So that's just great. So let's look at the code here, the more interesting code. First of all, I set the background to a slightly dark gray. And we can see a slightly dark gray, not total black, but dark gray. And we have created a variable called file, and this file loads in text.txt, which is this one. So now the program can access this one and do whatever it wants with it, or whatever we have coded it to do. And in this file we have set all the inputted words, we set it as a string, which is graphic type. Graphic type is string, so every word or character we see in this text file, I put it into the string here. So we can read in this document every single little word, which we have used pretty much to read in what we want and do whatever we want with it. So we can start in the beginning. So if this graphic type reads in the word image, it's nice, image here, great. And then we divided the next 5 words or integers, numbers, into different variables. So the image here is a string variable, and this reads in time.jpg. So now we can simply refer to image, and thereby we are referring to the word time.jpg. And the x, y, width, and height, and that's pretty much logically the x and y coordinate of the picture we want it to be. Those two we want to be in the picture, and we have the width and the height of the picture. And then we load in the picture based on that location we have written here. And then we set the color of the picture, offset the color to a total white one, because also it will be affected by the next thing we have loaded in here. It was a set color, but I'll come back to that in a moment. And then we simply just draw the image based on those variables we have loaded in from the text file here. That's great. So now we load in the image. Pretty nice. And then I'll look at some graphical functions. And the first one is set color. So if our string here reads in set color, then it will say the next 2 variables, next 2 numbers, three numbers. I'm saying 2, 3. Next 3 numbers, which is those here, they'll be converted into integers, 3 integers, and those I will put with those I will putting inside this offset color function, which sets all the graphics we see to a certain color. That's pretty nice. And then we look through the document again, see if we can find the word rectangle and the four other things coming afterwards, the word triangle, saying that to X position, Y position, width and height of the rectangle. And then we create the rectangle by the ofRect function. Pretty simple. And then pretty much doing this again by the circle. We're looking for the word circle. Then we are setting the two next numbers as a position and the radius. And the reason why I have only one position here is because I wanted to be at the same place, so I didn't bother writing 202 times. So it just simply create our circle based on a circle point. So it's point 200, point 200, which is the middle of the circle, and then the radius of the circle. Pretty nice. Creates a circle. Ta-da! Creates a circle here. It's nice. And then we will we'll fill or not fill the objects with a color. So we go into our document again, see if the graphic type can read the fill, and if they can find the word fill, then we fill those objects with a color. So we can change that word, because right now it's no fill, which says that the object shouldn't be filled with any color at all. So we can simply just go into the document, ta-da, there is no, save it again, it's cool, click up, and there, updated. That's nice. Then next up we create our ellipse, and we try to look up the word ellipse, and we set the y-x width and height of that, and create the ellipse based on that. It's pretty simple, and we're pretty much doing the same again. Triangle, look for the word triangle, and then we read in 3 pairs of coordinates for x and y, and put those into three lines here. And those are just connected, so it looks like we have a triangle, but it's just 3 lines. So that's why the lines aren't filled. The triangle isn't filled when we write fill here. So next up we have the width of the lines. We look after the word line width, and with that, then we just put in the next number we see as inside the variable with L, which is an integer, and set the line width to whatever it says in the document. So this time it's 3, and the line width is this line, and the line around those objects are 3 pixels thick. That's nice. And now for the more advanced stuff, we can say. And we are looking for the word scale in our text document, and with scale after scale we are setting the next word inside S image, which is the location for our picture, what kind of picture it is, and then 5 numbers we're putting inside the integer for x, y with height and scale factor. And we take our pointer data, put it inside a new on-site jar, and there's a huge chunk of data based on the width and height, and multiply that by 3. That's nice. So we have a huge chunk of data here, and then we allocate some space for the texture for the image, which also are based on the width and height we have here, and then we set it to a colored image. And we'll load in our picture based on the location we have written in the text document, and then we get all the information from the pixels inside the picture tunnel and put it inside our pointer pixels. Then we have 3 nested folders, and with those we are reading in the data for every single point that has a x, y, and z, which is for colors. So x, y times by 3, which are all the colors RBG, 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 and put it equals to our pointer pixel, which I'm pointing at picture. I'm pointing at the value of the pixel inside toggle. And what is important here to see is that in the data we have divided our y and x, those two, the height and the width. We divide that by the scale factor we have defined in text document, which is right now 3. So we can determine how many times the picture should be scaled in and out. And right now it is as an integer, so we can't put it as point at anything. So that's just simple. And we set the color of the image to bright white. So because else the picture will be infected and filtered by the set color we have placed here for the graphics. Okay, and last off we load in the data for the picture based on the data here, which is this huge chunk of data, and the width and height, and of course that should be RPG that color the picture, and then we just draw it. Pretty simple. And all these graphics are inside a do while loop. So we do all this once, woohoo, until we find the while. So while we are not at the end of the file, we do this once, and then we say check if we are not at the end of the file. Around that, okay, so file close. We'll close the file afterwards. And since all this is inside the function draw, then it will run totally again and again and again and again. So that's why, even though we are inside a do while loop, and the do while loop only should do this once, we can change it all live here. Scale factor 2. Nice. So the picture is scaled up again, and we can change everything in here as we want and see the live reaction on our output window here. That's pretty nice indeed. No fill, no fill.